In this video, let us discuss about subroutines. Now, first of all, what do you mean by subroutines? Already we know this. Actually, in high-level programming languages, we use the terminologies like functions, methods. In procedure-oriented, also called as function-oriented programming languages like C, we use the concept of functions. That means we divide the programs into different tasks, and for each subtask we are writing on separate code to perform only on that particular task and on different data. Whenever we want, we can call any number of times. Okay, that was a function in case of C. Same thing in object-oriented programming languages like C++, Java, we call the same thing as methods. Okay, so that means in high-level language, we are calling it as an functions or as an methods. Same thing in assembly level language. In assembly level language, that same function we call it as subroutines. Subroutines are nothing but simply functions or method, whatever you can call. That's it. In the high level language, we are calling as a functions or methods. Same thing in assembly level language, we call it as a subroutines. Let us take straight away one simple example of adding two numbers using functions in C. Okay. So as usual, again, always we know that it will start from main. So I'm not including the header files, all those things including. So I'm declaring two variables int a comma b and result one variable res. Okay. So printf. So enter two numbers. Then I'm reading scanf. I'm reading simply sf and pf. Okay. So percentage d, ampersand of a, ampersand of b. I read the two values a and b. Now what I am doing, I am calling one function called add and I am passing these two as a parameters. Okay. So now, and whatever it will returns, that I am receiving in one variable called res called result. Now I am saying, I am printing that result is equal to percentage d. So res that I am raising. Okay, this is my main function. So now when I call this function, so now I am writing, so since it is returning one integer value, the return type of this function is int add, so int x, int y. So now whatever the a and b value I am passing, that I am receiving in x and y. Okay. So now I am simply saying return x plus y. That's it, over. Now this is my function. This is my main function. So main function is calling this function. That means this is my what? Now this is my totally this is my one program. Okay. So this is my one program. Okay. Now here this is okay. This is what my calling subroutine. Calling subroutine instead of calling function, now we'll call it calling subroutine, and this is called by this, so hence I will call this as an called subroutine. Actually it is a function, but since I'm discussing in high level language, I'm calling it subroutine. So this is a calling subroutine because this is calling this function. This statement there we are calling as a function calling statement. So here it is called calling. Okay, calling subroutine. This is a called subroutine. So now, see, assume our processor starts executing. Always our execution start from the main. So it enters, it executes this statement, this statement, this statement. When it comes to this statement, when control comes to this statement, now this is a calling statement. It is not a general statement or not ordinary statement. It is a calling statement. Now control comes to what? When comes to this one, control comes to this statement. Okay. Now see, it stops here. It is not executed here. When I call this function, it comes to this one. Now it execute all these statements. Once it return, after this statement, again it goes back to the it goes back to the statement where it was stopped earlier. Earlier, this program was stopped here. Now from where it has to continue? Here only. Exactly, it will return here only. Summary is, whenever the calling subroutine calls a subroutine, it stops the execution of currently being executed subroutine and control will be transferred to the called subroutine. And after executing all the instructions of the called subroutine, again control transferred exactly to the statement where it was stopped earlier. This is the method or the procedure. But now the question is, how our processor came to know that I have to return back to this statement only, because I stopped here and to continue from here only. How it will came to know? Okay, because see, again, I told in many of my videos, we human beings, we are having eyes. We can see, okay, control comes here, after executing all, again it has to continue from here. For example, see, we are watching some video on our system, okay, or on our mobile. So, call came. So, our video will get passed. Immediately after completing our call conversation or disconnecting or answering, exactly where we stopped from that onwards it will play. How our system will came to know that I have to continue from this point. Similarly, how it was the processor will came to know I have to continue from this statement till it is over. From here I have to continue. How it will came to know. That is the concept. Okay, that we are going to discuss in different subroutines. Okay, so in order to do that, so let us say, so I will write some addresses, okay, for your references. I will write some addresses. So let us say, for example, generally I will take the addresses 1000. So okay, let us take this as a first start. This is in the 1000 address. This is in 1004, 1008, 1012, 1016, 1020, 1024, 1028. Assume this function starts from say 2000, for example, 2000, 2004. So this is 2008, 2012. This is my addresses. Okay. So now we know that we are having one special purpose register called program counter PC. This PC contains the address of the next instruction to be executed. Next instruction to be executed. That will be held in this what program counter. This one special purpose register. Always our processor know which is the next instruction to be executed. That address will came from PC register. Okay. Now with the help of PC, we can do this task. Now, whenever a call in subroutine, whenever our one subroutine calls another subroutine, what happens? Now, assume I told when our system is executing, our processor executing this system. See, when we are executing this statement, program counter contains what? Program counter contains the next. See, current time executing this. This is next instruction. This is next instruction. So program counter contains this one. Similarly, when executing this instruction, my program counter contains this one. When I'm executing this instruction, program counter contains this one. Similarly, when executing this instruction, program counter contains this one. When I'm executing this instruction, now program counter contains this address. When my processor executing this instruction, program counter contains this instruction. Now, whenever our subroutine calls another subroutine, the content of program counter will be stored in one special purpose register called link register. Okay, this is one link register. Again, this is a special purpose register. It will make a link between the two subroutines. Hence, the name is called link. Okay, so now whatever the value, that means address stored in the program counter, that will be stored in the link register, and then it will go to the control go to the specified address. How I'll get the address of this add function? Name. I told in many of my videos, always name of a function, name of a variable. Name is nothing but some given to the address. Name is address. So I know this address, go to this address. Now it will change, the program code will be overridden by this one. Let us take another example. So now let us take one simple example. I have written a complete program. Now in general return. So this is my calling program. So like my main function, and this is my subroutine. So like I just add only. So now this is the memory location. You see, so some statements are there, some blah blah statements are there, and here some statements are there. So now after some statements, I'm calling a subroutine add. See, in programming language, so we are calling the function by its name. So How, so who is responsible to transfer the control? See, when we call the subroutine, now control is transferred from here to this one. That means when we call any subroutine, so control has to be transferred from one program to one location in the program to another location of the same program. So that will be taken by one special instruction called call instruction. Now this is the instruction, how we use move, add, sub, like that one. So this is one instruction. So this is calling this subroutine. This is the name of the subroutine. So subroutine name add. Okay, when I do this one, now control goes to this location because add. So this is the name of the subroutine and the name is address. The starting address is 1000. So now it know. So it will go to this one. Now before going, see, when we executed this instruction, my program I'm having one what? Link register. So whatever the program counter, now program counter contains what? When I'm executing this instruction, program counter contains 204. So this 204, whatever is there in the content of the program counter, that will be loaded into what? Link register. And then after storing this one, my program counter will be updated by the instruction where it wants to go. Now where it wants to go in the address 1000, so it will be updated with 1000. Now control shifted to this 1000 and it executes all the instructions. When return instruction is executed, now return instruction take the content from the link and then it will goes back to the exactly to this one 204 address will come. So that address is there in the 204, that is the link register. So the link register makes possible to transfer the control from the calling subroutine to the called subroutine, and after completing that action, called subroutine return to the calling subroutine to its caller through the link register content. So hence you call this register the link register. Now you people understood what is subroutines, how to control be transferred between the calling subroutine and the called subroutine. Okay, I hope it is clear. Now the question is, suppose here only one calling subroutine, only one subroutine I am calling. Suppose there are multiple subroutines are there and one subroutine is calling another and that is calling another. Like that, when we are having nested subroutines, then how it will be done? So that we will see. Okay. Now for that, let us take one simple example. Now assume this is my main calling program. My calling program. Now assume it is calling one what? Subroutine 1, and subroutine 1 is calling, assume another subroutine called subroutine 2, and finally it is calling the last subroutine 3. Okay, so now assume for some data is there already. Okay, some data is there. Assume it is calling, say, subroutine R1. Okay, now the control should go to what? Here. So now here it is something. After that, again it is calling subroutine 2. Now it is going here. Now after some statement, again it is calling subroutine 3. Now again it is going here, some statement. Finally it is returning. So when it is returning what? So assume exactly I am having these statements after that. Now we know that once return statement is executed, control should return to its position where it was stopped earlier. Now it has to stop, come to this one. Now assume this is my last return statement. Okay. Assume after that I am having last all return statements are there. Return statements are there. So now when it returns, it has to return exactly where it was stopped earlier. Now again this will go back to here. Now the question is, and we are having what? We are having one link register and one program counter. We are having only one link register, one program counter. Now let us take for example, this some address are there. Assume this address is 1000. Now this address is say 2000. Okay, this address is, for example, first instruction 3000, 4000. Okay, now assume 3004, 3008, 3012. This is 3016. So 2000, 2004, 2008. Next is 2012. Now this is 1004. Okay, something. Okay, now I'll start. This is the main function. Okay, calling program. When I call the first subroutine when I'm executing this instruction. So what is the program counter contains? Program counter contains 1004. That will be pushed into what? Program counter contains 1004. That will be pushed into link register. See, before it going. So 1004 comes here. Now once it 1004, now from the subroutine 1 starting address of 2000, that will be overturned here. Now control goes to 2000. Now I am here. Now, after executing these statements, assume now I am executing this statement. Now, this statement when I am executing, what the program counter contains? Now, program counter contains 2012. Now, that will be pushed into the link register 2012. So, now after that, so this subroutine 2 starting address is what? 3000. That will be pushed into the what? Program counter. Now it will go to 3000. Now right now in my 3000. Now assume I am executing this statement. Now program counter contains what? Now program counter contains 3016. That will be stored in the link register. After that, this 4000 will be stored in the 4000. Now it will go to 4000. Now control is the 4000. Now all are straight instructions. Now once a return address it will come, it will take from the link register, it comes to 3016. Exactly fine. This is done. Exactly done. Fine. Now when it is executing this return, it cannot come to here. Why? Because this data we are not at all stored. See, we link register is having only 3016. The link register is having only what? 3016. It can only come to the last but one. But from here on it cannot come back. This is the problem with the nested subroutine. That means when the nested subroutines are there, nested subroutine means when one subroutine is calling another subroutine. At that time, so our link register will keep overwriting, so that we can come only from the last called subroutine to its caller. But from there onwards, we cannot come back. This is the problem with the link register. This link register works fine only when what? Only one calling function, only one subroutine is there. That's it. Only two functions, only two subroutines are there. Works fine. But when we are having multiple subroutines like this, it is not possible to come back, because content of link register will get overwritten. So now what to do? So for that, we go for the one more data structure called stack. Why we need stack only? See, here which is the last subroutine which is called? Last subroutine is called is subroutine 3. This is the last one called. Who is called first? This is the subroutine called first. Now, this is the last one. So, from here we are coming first. Whichever we last we conduct, that will come. You see, this is the first in, this is the last. Okay, but this is the last first out. So, this is the first in, last out, or last in. So, this is the last in, this is coming or last out. So, suitable data structure for to implement this is stack. So, whenever instead of storing the what? Program counter just addresses in the link register, only one link register, we are using what? Stack. One stack we are using. So in the stack, we know that stack pointer will be there. Stack pointer will be there. Now, whenever we are going from call subroutine to here, I will store this 1004 to, I will push it 1004. Because this is the return address for the last one. Now, when I go to here, so again, when I calling here, so this address, this return address is what? 2012. That I will push and I will go. When I'm calling here, I will push this 3016 and I will go here. Then 4000 will execute. When I'm returning back, I will pop it out. I will come to what? 3016. Fine. After executing that again, I will pop it out 2012. I come to here. So fine. After that again, I will get 1004. I will come to here. Fine. I will pop it out. So this is how nested subroutines will work. So that means summary is, when we are having only two subroutines, that is calling and as well as only one call, at that time we go for the link register. If you are having nested subroutines, we are storing the return addresses in the what? Stack. Okay. This is what the nested subroutines. Now, see, we discussed how control will be transferred between the one subroutine to another subroutine. But here not only control is transferred, but in this example, if you see, it is passing some data. See, A and B it is passing. It is receiving A value, B value in X and Y. And it is sending the result X plus Y, one value it is returning. And it is receiving that one. Then how those values, that is the parameters are passed. So that means parameters are passed between the what? The two subroutines, again using two methods. One is using registers. Suppose we are passing very few parameters like 1 or 2, 3. At that time, we can, whatever the parameters we are passing, we are storing the parameters in the registers and we are controlling the transfer. Because registers are inside the processor, it will take. But when we are having multiple parameters, let's say we are using arrays. Arrays we are using some 20, 30 elements. So it is not possible to store 20, 30 values in 20, 30 different registers because we don't have that many number of registers. So again at that time, whenever we are calling the subroutine, so first we will push the parameters first. Suppose we are calling this one pushing, so first I will push the value of what? First I will push the value of A, then push the value of B, and then I will return address of this one. Return address of this one was 1024, and then I will go back. I will go here. So now here, whatever the value it is done, again that I will push, and then I will get the pop and I will return back. Okay, that means if very few parameters are there in the calling subroutine, passing, one subroutine is passing, so we are using registers. If more number of parameters are there, it is better to use or stack. So whenever we are before control is transferred, we push all the parameters and then the return address, and then we're coming back, we'll simply will get this 1024 or return. That's it. Okay, this is how the subroutines are very much useful in case of any programming language. Whether you are using C, C++, Java, .NET, Python, which are the programming language, whether you are using methods, whether you are using functions, in both. So we have to use what? This concept of subroutines as a system software in our system. So it is very important for any computer science students to understand how the control will be transferred from one function to another function, or from one method to another method, or from one subroutine to another subroutine. Hope you people understood. If you have any questions, please write it in the comments. Thank you. Thanks.